Hey guys, today 6.5, this section is the last section before spring break. So we're just going to solve some equations containing radicals. Okay, here are the steps to solve it. It's very straightforward. You're going to isolate the radical term. Okay, this should be a word term here, right? Oh, that's not that R. Okay, great. Isolate the radical term. Okay, look, I can write. So you have to isolate the radical term because whatever the radical has in it, right? You got to get that by itself, and then once you get that by itself, you can raise both sides of the equation to that power, in which will cancel out that radical. Okay, and then you solve it. Right? The reason I say the radical term is because you don't want to make it more complicated than it normally is by doing some dividing to just get the radical by itself. So if it has a coefficient in front of it, just leave it with it. It's a lot easier to square that rather than do some dividing and make it more complicated. So let's jump right into solving some of these. All right, we'll start with some pretty simple ones. Okay, we got to isolate the radical term here. All right, isolate that first. We'll add 3 to both sides. We'll have root 2t minus 1 equals 3. Then we have to raise this both sides of our equation. Okay, I need to get rid of that. It's in my face. Okay, so we're going to raise both sides to the second power. We're going to square both sides. Okay, so that way this radical goes away. So we're left with 2t minus 1 equals 9, and we can solve from there. So 2t equals 10 and t equals 5. Now, once you get here, it's really important that you always check your answer back in the original equation. Right, you have to check it back in the original equation because when you square or cube or fourth power or whatever to both sides, you might lose some roots, and it's called extraneous roots. So things that work in our little mathematical model, but because we're manipulating this equation, it doesn't always, all the answers that you get don't necessarily work for our original equation. So we need to double check it. So we plug this in, and we're going to have 2 times 5 minus 1 minus 3 equals 0. Okay, so we've got 2 times 5 is 10. 10 minus 1 is 9. Square root of 9 is 3. 3 minus 3 equals 0. It does work, right? So 3 minus 3 equals 0. Good. Checks out. We're all good. The answer is t equals 5. Next problem. Okay, now we've got 2 roots in here. It's still not overly difficult because both of our roots are already isolated, our square root terms, so we could just square both sides. Alright, all these go away. Makes this very simple. X minus 10 equals 2x, and x equals negative 10. Okay, but make sure you plug it back in and make sure you get the exact same thing on both sides to make sure this isn't an extraneous root. So we've got the square root of negative 10 minus 10 equals square root of 2 times negative 10. So we've got square root of negative 20 on this side equals the square root of negative 20 on this side. Now we know that we can't take the square root of a negative number yet, so this is actually not going to work out. So this is an extraneous root, and the answer is no solution. That's why it's so important for you to check your answers. Now this equation right here, there's also some times when you don't have to square both sides in order to get our answer, right? And that's going to be the case whenever our radicals don't have a variable in it. Okay, if you just have radicals with numbers on the inside, then you could still just solve for whatever your variable is. Okay, so for this one, all we have to do is divide both sides by root 2. We've got x equals 8 over root 2, which we need to rationalize, which we're so good at this point that it's not even an issue. 8 root 2 over 2, which is 4 root 2. Okay, that's the answer. Now, those types of problems, when you don't have to square both sides or cube both sides or whatever, you don't really need to go back and check. You obviously can check because it's just good habit, right? So 4 root 2 times root 2 is going to be 4 times 2, which is 8. So that works anyway, but you don't have to check. It's not as paramount for those types of questions. Okay, more of this, okay? So this one, once again, there's no variable inside our square root, so we can solve this without squaring both sides. That's what we're going to go ahead and do. Now, the way you do that is you think about what's going on when you do 3x plus x root 5. Okay, well, what you're actually doing is just adding the coefficients, right? If this was 3x plus 5x, we would just put 8x because it's 3 plus 5. So this is the same as 3 plus root 5 x. Okay, That's equal to 2. So now you can just divide both sides by 3 plus root 5. Now have x equals 2 over 3 plus root 5. And luckily, in the last section, we just learned how to multiply by the conjugate to rationalize this. So we've got times 3 minus root 5 over 3 minus root 5. Distribute your 2. We've got 6 minus 2 root 5 over, let's see, we'll have 9 minus 5. Okay, so actually let's keep that 2 on the outside. Let's factor the 2 back out. Okay, so we can do some simplifying. And we'll have 2 times 3 minus root 5 over 4. These will go away. And the final answer will be 3 minus 5 over 2. Okay, once again, it's not a huge deal. You don't have to check your answer on this one because we didn't square both sides. But if you'd like to, you're more than welcome to. Okay, this one you're going to have to go back to squaring both sides. So we have to first of all isolate this term that has a radical in it. So 3 root x plus 1 is going to be equal to 1 plus x. Now we have to square both sides, so the radical goes away. Remember, we got to square the 3 and the root, so the root will go away. But when we square the 3, it's going to be 9 times x plus 1 equals, when you square this out, we're going to have x squared plus 2x plus 1. So we can distribute our 9 and then subtract everything over because we're going to have a quadratic. So 0 equals x squared, 2x minus 9x is minus 7x. Oops. And 1 minus 9 is minus 8. Okay, so 0 is going to be equal to x minus 8, x plus 1. So x equals 8 and negative 1. Now, do have to go back and check and make sure both of these work. So we've got 3 times, let's try 8 first. 8 plus 1 is 9, so 3 times 3 is 9. 9 minus 8 is 1, so 8 does work. All right, if we try negative 1, we've got negative 1 plus 1 is 0, so square root of 0 is 0. The 3 you don't need to worry about. So we got negative 1, which is positive 1, equals 1. So both of these do work. Number 6 here. Okay, we're already isolated. This one is going to be one where we have to cube both sides because we see our index here is a 3. Okay, so we're going to cube both sides right away. Alright, cube and the cube root go away. We've got x squared plus 2x on this side. And 2 cubed is 8. So we could subtract it over. We see our equation shaping up here into something we can factor. It will be x plus 4, x minus 2. And so x equals 2 or negative 4. Now let's check both of those. Alright, we can write them out. I'll go ahead and write this one out since I didn't write the last one out. So we got 2 squared plus 2 times 2. We want to see if that's going to equal 2. So 2 squared is 4. 4 plus 4 is 8. Cube root of 8 is 2, so 2 equals 2. That one is good. Check the other one. Cube root of negative 4 squared plus 2 times negative 4. See if that's equal to 2. So negative 4 squared is positive 16. Positive 16 minus 8 is 8. Cube root of 8 is 2. So that one's also going to work out just fine. Okay, so they're both good answers. Now, the number 7. Now, this one looks very, very similar to the one we did up top. Remember, we had 3x plus x root 5. Now we've got 5 root x. So since our variable is under the radical, that means that we're going to have to square both sides. It's the only way you're going to be able to solve for x. So we need to isolate this term, this radical term, before we do anything else. So we have 5 root x equals 2 minus 3x. Now is when we square both sides. Remember to enact that squared on both terms, and then on the right side we're going to have to FOIL. So we've got 25x equals 4 minus 6x. Minus 6x is minus 12x plus 9x squared. All right. Now we can get everything to the right side and factor. So 0 equals 9x squared minus 37x plus 4. That we need to factor. And I think automatically I see this 9 and this 4, and I think of 9 times 4 is 36, and I could have a 1 in there to get to our 37. So when I factor this, we'll have 0 equals 9x, let's see, minus 1, and x minus 4. Okay, negative 1 times negative 4 is positive 4, negative 36 minus 1 is negative 37, so this does work, and that tells us that x is going to be equal to 1/9 or 4. Okay, so before we are finished, we have to double check both of those equations, or both of those in our equations. So 3, let's go ahead and write this one out. So we got 3 times 1/9 plus 5 times square root of 1/9 equals 2. So the way this works, we've got 3 times 1/9 is 1/3 plus 5 times 1/3, right, is 5/3, because the square root of 1 is 1, square root of 9 is 3, equals 2. That is true, so that one works. Now try it with 4. Got 3 times 4 plus 5 root 4 equals 2. We got 12 plus 5 times 2 is 10, way bigger than that. Okay, so 22 is not equal to 2, so that one does not work. So our 4 goes away, and the answer is just 1/9. Now the last problem here is the hardest one, because you're going to have to square both sides twice. Alright, it's real sneaky, tricky stuff. Alright, so let's get everything by take this term, get this by itself first to get rid of that one. So we got root 2x minus 2 equals 1 plus root x plus 6. Now we square both sides, and this one will go away. Left with 2x minus 2 equals 1 plus 2 root x plus 6 plus x plus 6. Right, now we can get everything over and isolate this term, and then square both sides again. So we'll subtract some stuff over, and we're left with x. Right, when we subtract the x over, we're also going to subtract a 7 over, so x minus 9 equals 2 root x plus 6. Square both sides again. We'll have x squared minus 18x plus 81 equals 4x plus 24. Right, because it's going to be 4 times x plus 6. Okay, now we can solve for everything. So we got x squared minus 22x plus, when we subtract that 24, we're going to get 61 down to 57 equals 0. The only thing that I know of that goes into 57 is 3 and 19. So x minus 3, x minus 19 equals 0. Those both work. So x equals 3 or 19. Now we've got to plug it back in and check. Okay, so we've got square root of 2 times 3 minus 2 minus square root of 3 plus 6. And we want to know if that equals 1. So we've got 2 times 3 is 6. 6 minus 2 is 4. Root 4 is 2 minus 3, right? Because we've got 9, square root of 9 is 3, equals 1. Well, negative 1 does not equal 1, so that one does not work. So 3 doesn't work for us. Well, we'll try 19 to make sure that one works. 2 times 19 minus 2 plus 19 plus 6 equals 1. Oh, not plus, it's supposed to be minus. Good. Okay, so 2 times 19 is 38, minus 2 is 36, root 36 is 6, minus root 25 is 5, equals 1. That does work, so 19 is our one answer. That's all.